Today's session, as you can see on your screen, it's called Build Vector Embeddings for Video via Python Notebook plus OpenAI Clips. And the presenter is Akmal. He is a very regular speaker at our webinars. And my name is Yukti Divedi, and I will be your host for this webinar today. So if there's any feedback, any ideas for future sessions, or if there's any projects that you're working on and you would like for us to cover, like how single store can actually help you accelerate it. We'll be happy to do a session on that as well. So if there's anything, feel free to hit any of us on LinkedIn, or maybe you can email us at team@singlestore.com. So if you like this topic, you can tune into future webinars that actually the landing page for the future webinars is not exactly ready, but you will see them pop up in your like on our resources page very soon. But on 16 December, we have full text search version, and Akmal can actually talk more about it. It's a very interesting topic, and Akmal is working very hard for the demo, and thanks so much for that. And obviously, we have a QR code that's going to redirect you to the landing page for today's webinar, because in case there's anything that you want to read through. So just an FYI that this session will be a hands-on session, and you can follow along in real time to make use of like most of to make most use of your time. So um, we Akmal will actually walk you through the cloud trial process. So it's absolutely free of cost. We recently have also announced a free share tier. So if you and I'll be giving you the resources for everything in the chat, just like so that you all know that you are currently in a listen only mode, and um you can interact with us using the Zoom Q&A button, which is present at the bottom of your console. And Akmal is going to take care of those questions. And yeah, if I can also answer a few of them, I'll also chime in, and I'll take care of your queries. So if you miss anything, if there's any doubts, just feel free to prompt us in between and we'll take care of it. I think that's all from my end. And Akmal, please take it away. Thanks everyone for joining.
Yeah, great. Well, thanks very much, Yukti, and thank you all very much for joining. I know it's getting that point in time, and I was just discussing it with Yukti a short time ago that we are approaching where are we? We're in almost mid-December now, and so people are starting to wind down. It's vacation time, holiday season, and so I think gradually people want to have a bit of rest rather than worrying too much about technology. But anyway, we're not quite there yet. So we've got, as Yuki pointed out, we have today's session, and then I think we have the session next week on full text, and that will probably be it for December, I think, unless there is some urgent demand from yourselves for us to do something more. So please do sign up. Okay, I will talk through this process momentarily as well. So, okay, singlestore.com/cloud hyphen trial. Okay, so you will share the link to the GitHub repo, and I'll work through the notebook. The slides, if you've been following along and you attended the session earlier this week on Clip, and then the other one that we did prior to that, which was, I think, Friday last week. So we're doing elements of Clip. So we started off fairly simple stuff. Then we looked at kind of e-commerce type scenario earlier this week. Today, we're going to look at how we could use Clip for videos. So it's a very versatile piece of software. It's free. Okay. And one of the challenges, as you know, is that with commercial LLMs and software in general, you typically need some kind of API key. And especially for commercial environments, normally you have to sign up and you've got to provide your credit card if you want to do anything serious. It's always great to have an open source alternative. And Clip is one of these technologies that is open source. And it's wonderful in the sense that you pay nothing, right? It's free, and that's one of the nice things. Two quick points before we move on. So if you attended the session on Tuesday this week, I referenced CDN. I was constantly using the phrase content development network. I have no idea why I said that. It's content delivery network. Okay, so this is where we're hosting these images, where we're downloading them for use locally. So that was the key thing. I have no idea why I was using that phrase, but just to clear that up, no one corrected me, so I thought I better do it myself. All right, so uh, there we go. So this is the sign up page. Okay, so please do take a moment to do that if you haven't done so already. Okay, so singlestore.com/cloud-trial. Quickly, you can use Google or Microsoft or do it the old-fashioned way, just there and click continue. Okay, so it'll ask you a few questions. Okay, and then there's a wizard and just walk you through the process, send you an email, just confirm that you are human. And then once you've confirmed and you sign in, and if this is the first time that you sign in, your environment will look something like this. Okay, let me just go to the home page. You will get a hello, sort of message here. And the two things that you need to be aware of and will be useful to is on the left-hand side, you'll see there's a kind of a navigation pane. Okay, so let's just get you started here and then we'll go through the few slides that I have. Okay, so check under deployments here. Okay, which is just here. So as you sign into this environment, automatically there should be a workspace, okay, which you need. These are the kind of compute resources that you need to run, and a database. And this is the starter tier, okay? So that should be automatically created for you and up and running. If it isn't, all you need to do is just go to the top here, okay? And just select the pull down, as you can see here, and you can configure this. There is an option here, new deployment, as you can see, right? So currently I have this, my starter workspace, running on AWS. That's fine. Okay. So there was a time when you signed up for this where you had to provision it yourself. Now what the team has done, the Helios team has done, the cloud team, is that as you sign up automatically, when you log into the environment, a starter workspace is running for you straight away. In other words, you hit the ground running. There is nothing additional to do. If you do need additional resources, you are welcome to create a new deployment if you wish. And if you do that, you'll see that the starter is ghosted out because it's running already, and you're only allowed one of these. But the standard is fully available here, okay? And they give you $600 worth of credits, so you can configure this and you can choose your particular cloud provider. The starter tier is on the AWS platform. There's no choice on that at the moment. That may well be available as something to configure in the future. I'm not sure. We'll see how it goes, okay? And then again, you've got more options with the standard in terms of CPU and memory, and basically you can choose your region as well here. So I could pick something a bit closer to myself here, Europe West to London, okay, which would be for me. And then down here, oops, just trying to be a bit too clever. And just click next here, okay. Let me do that. And then here you can see you have the option to really configure the size using this edit button, okay, which will give you control. And again, it will tell you how many credits you will burn through per hour based upon your choice of CPU and RAM. And as you can see, if you're sharp-eyed, on the right-hand side, I've got 43.45 credits still left. How that maps into dollars, off the top of my head, I can't remember. There is a formula for this, but that's still quite a lot. Okay. In any case, I have the standard tier. Okay, I've used it before in other cases, but for this today's example, the free share tier will be absolutely fine. Okay, you don't need anything else for that. We're not going to do something drastic that you will need huge amounts of memory and CPU. Okay. So that's the one thing there. And then the other thing you need to do, and I'll just quickly show you that. Okay, so you can grab that as well whilst I'm showing the few slides, is if you go to the left-hand nav again, the other thing that you need to look at is, okay, Data Studio here. Okay, let me just highlight that for you. Okay, so remember it was deployments. Just make sure there's you've got compute and database already. And then for Data Studio, if you select this, like so, there you can see I've got a notebook up and running, or actually two there. There are two tabs, but look for this thing here, browse, okay? Your environment, if you're using this for the first time, it'll be empty, okay? So just select this, and as you can see down here, I've got a whole bunch of notebooks I've been working on these past few days. But the thing that you want to look for is this big purple button on the right-hand side. And if you pull this down, you'll see two options: new notebook or import from file. And import from file is the one you want. So Yuxi will share the link of the GitHub repo in the chat. Okay, so if you go to the repo, and I'll show you that, it will be like so. This repo is a bit larger than the one we used earlier this week and the one we used on Friday last week, because you have not only the thumbnails, but we have some videos here as well. Okay, so there is a folder for the notebook. There's some thumbnail images here and some videos as well. And there's actually an article that accompanies this as well, which is down here. Okay, the link to this is on Medium. So if you'd like to see that, let me just show you that. Okay, so that's something to read in your own time if you wish to do so. Okay, so hopefully any questions, okay, just post them in the link there, and then we'll take a look at those. So hopefully that will give you enough to get going on. Meantime, I'll just go through a few slides. Okay, so we'll keep it relatively short today. The notebook itself that we're going to use from the GitHub repo is actually got a lot of comments in there. I took the time and opportunity to write up a fair amount of information in there, basically describing each of the steps in detail, which for the two previous webinars, we didn't do so much simply because they were actually very simple and straightforward, in my humble opinion. So let's just quickly do the standard who is single store slide, okay, and the architecture slide, and then we'll move on to the demo shortly after that. So as a company, we've been around for quite some time, okay, 2011. Originally, both the product and the company were called MemSQL. You may have heard of us, focusing on in-memory processing for OLTP. Subsequently added support for columnar support. You see, it's here, column store, okay, OLAP. And then sometime later actually rebranded to single store. Simple reason is that you're no longer doing sort of in memory, so the mem part doesn't really make sense. A couple of points here. We'll be using the vector type today, but vector support has actually been in the product since 2017. All right, so it's mature, tried and tested, used in production environments. And just summarize here. So we are a $100 million plus ARR company, okay, and over 400 global customers. Some of them you can see down below. Some of the investors, they're actually customers as well. And then in terms of the product itself, well, combining both the OLTP and the OLAP into this concept called universal storage. And we can integrate very easily with a variety of technologies. And I think Yuxi has in her schedule for future webinars where we will talk about Kafka integration, and we've got Spark as well. But if you've got data on other platforms as well, say S3 or Hadoop HDFS, very easy to ingest that at scale using this concept of pipelines, okay, which is the animation there. We do work on all three major cloud providers in the Western world. Okay, so AWS, Google Cloud, Microsoft Azure. Today, we will be using AWS. Okay, if you use and select and have created an account, excuse me, automatically the free shared tier will be on the AWS platform. You can run on-prem, okay, which I think is important to some customers. When we have banking customers, for example, financial customers in particular, that have some restrictions and limitations of where they can keep their data and where they can process it as well. So they prefer to run on-prem, which is fine. Okay. Stored data types, the product is relational at its heart. That's where it started, but we've covered in past webinars geospatial, time series, We've done JSON as well, and vectors. Okay, let's use that a little bit today, and we've done that in the recent past as well. And then just to round it off, a variety of other tools, applications, real-time analytics that you could use as well. All right, so some of the ways that you can use AI and ML with single store. This is not an exhaustive list, just some examples. I happen to have some experience with Spark. I worked for Databricks in the past. And today we're very much going to use Python. We will use this dot product. Okay, today you'll see a little bit of that in the SQL code. Out of the box, single store supports Euclidean distance and dot product. If you're interested, cosine similarity, you can just code it up in SQL. It's actually covered in our docs. Very straightforward and easy to do. And if there's something more exotic that you want, or something that you want to add additional sort of functionality and capability to the system, the easiest way to do it is just use WebAssembly. So there is this code engine using WebAssembly. I think we have customers that have actually done that as well. So C, C++, Rust, for example, just package that up as a UDF, load it into the system, and then you extend the capabilities of the database system. And that code runs in a separate environment. So if there's a bug in your code and it crashes, it will not bring the entire database engine crashing down as well. Okay, so that's a very useful feature. For vector search, so if you've attended the two previous webinars, you will have seen this slide. So essentially, if you think about it, what we have seen, particularly with the advent of LLMs, and if you go back roughly 2 years now when ChatGPT was first released, very much focused around the concept of text. That's what we typically use. You know, you're having a chat, hence the word ChatGPT. So think about a phrase such as this. You know, the quick brown fox jumps over the lazy dog. However, text is just one representation. We could have, say, an image. There could be an audio file, for example. So I may speak, my words could be transcribed to text, and then the text could be used as a way to communicate and query the database system. We may even have videos, for example. I think this is the representation here. And so what we're trying to do is get to a point where we have a means to be able to represent this data in a format that we can use. And vectors is the way we do this. And there are a variety of ways that we could achieve this. Okay, so using encoders, transformers, and so on. It just so happens that Clip allows us to do this without having to use anything external, beyond, in other words, going to say another piece of software such as an LLM or over the wire, over the network to some sort of SaaS provider, for example. And essentially, this is what it's doing here. We kind of treat it as a black box almost. Nothing particularly magical about it, but it's nice that it's able to take this representation, whatever it is on this side, and then give us a kind of a standard representation on this side, which then makes it very useful for us to be able to perform these kind of similarity searches, and it's great for RAG applications and so on. There's the benefit that we get from this. All right, and that's essentially it. So let's just go straight to the notebook. Hopefully you've been able to grab the Python notebook, the link that Yuki has shared. Let me just try and, okay, I think I've set the font size here to be a bit large so that we can walk through this. So if we just take the opportunity to scroll down here. Okay, so what we're going to do in this particular case is take a video and we're going to break it down into individual frames. And then each of those frames, then we are going to generate a vector representation of that. So we treat it as an image, and then we'll be able to do some searches on those images. So this is one solution, okay? And there are many other ways that you could deal with this, many other ways you could handle it, okay? But this is just showing you a simple way to do it free of charge, okay? There's no cost involved there. You don't have to get your credit card out for anything. And so we simply take the step here of installing some libraries. There are several ways that you could do this in terms of using clip. I happen to use this particular way, just do the pip install, and then it's getting it from GitHub, as you can see. Uh, we've got a couple of other packages, matplotlib we'll use as well, and um, a few other things here, IP widgets and so on, okay, in order to just handle the data correctly. So that's all we're doing there. And then the first thing we're going to do there is actually download a video. And this is a video from the GitHub repo. Remember, I showed you the couple of folders that exist in my GitHub repo, one for the notebook, one for the thumbnails, and one that contains 3 different videos. And this is one of those videos that we have. So this is actually available on YouTube as well. And it's actually nice to use because it's fairly short. It's 142 seconds long. So, it's not very long, just a couple of minutes in duration. And then all we are doing here is just simply downloading this and storing it locally within this Jupyter environment. Okay, so we've got some space here available in the cloud where we can download files and store them temporarily. And that's all that's happening there. So it will just download that for us. It's not a very large file. And then we take the opportunity to just play the video here. So I did that a little bit earlier. Okay, so once it's you run the cell, it will automatically play that. And as you can see, it's 2 minutes, 22 seconds, okay, in duration. So there we go. If I do this, just a little bit, okay, I won't run the whole thing, but this is one of the videos.
Single Store DB offers the world's fastest distributed SQL database used to power modern data-intensive applications. It unifies transactions and analytics in the same engine with high performance to power your modern applications or drive real-time analytics. So you no longer need multiple engines for operational and analytical workloads.
Okay, let me stop that there. Okay, so that's played about 28 seconds of that. That's fine. So if you take the time to view that video, you'll see there's some interesting sort of text you can see there at this particular point where I've paused it. So we've got a combination of text occurring, okay, like here, for example, and we have images as well here, for example, and here. There's a disk drive here as well, okay, with the old single store logo on it, and so on. So, excuse me. This is it gives us the opportunity to, certainly in terms of querying it, it gives us some reasonable, sort of variation, if I can put it that way. Okay, there's some different types that we can look at, and we'll do so momentarily. That's fine. So we've got our video, we've downloaded it, we can play it, and we can then take the opportunity to actually download the clip model. Okay, so this is what we're doing here. So this takes a few moments. It's 338 megabytes. I think my magnifier is not going to show that particularly well, but this takes, certainly when I ran this a little bit earlier today, about 13 seconds or so to download that. Okay, so that's fine. Our next task then is to simply say, well, okay, we've got the video. How could we manage this? And one of the ways that you could do this is to simply say, well, all right, I'm going to break this down into 1 second intervals. Okay, that will give me 100 and, you saw that it was 2 minutes 22, okay, 60 plus 60 plus 22, 142-second duration. So it'll give me 142 frames if we extract at 1 second intervals, all right? And this is what this piece of code is simply doing. Okay, so it's pulling out the individual frames and grabbing the frames at regular intervals. 1 second is the interval we've selected for this particular rate, and the frame rate, and so on. And then once all the frames are extracted, close the video file and return the list of frames. That's all we're doing here. Keep in mind that everything so far is just within Python. Okay, nothing is stored in the database yet. We'll do that a little bit later on. For each frame, then, we generate an embedding, and that's what's happening here. Okay, so we are taking the opportunity to say, well, all right, take the image, okay, and encode it, and this is what's happening here. You can see this just down here. All right. And then the next thing is just store these embeddings and image data in a pandas data frame. Standard stuff, okay? So pandas works really well. So again, you can see this function to handle that. And we're using TQDM to give us a little bit of information in terms of processing that. So here you can see it's done that for us. Now, if you run this, notice that, yep, it's 142 seconds in duration, okay, which is what it tells us here, 142 frames, but this is a slow process. So notice the time here, it took 6 minutes and 15.25 seconds to actually process that. So small scale, this is going to work fine. One of the things at the end of this notebook is I've listed a couple of limitations of this approach. There may be alternatives that you want to think about, especially if you're working with larger video files. I wouldn't recommend using this if you've got something that's several hours in duration. You're probably going to be waiting a long time for it to be processed. Okay, there's better ways of doing it. All right, for our purposes here, that's absolutely fine. It works well. 6 minutes is enough time for me to go and make some coffee and come back, and it's done. And then if we take a look at the head, take a look at the first 5 rows, you'll see here that we indeed have the embeddings created for us. Okay, you can see some examples here. Okay, and that is for each frame. So there'll be 142 rows here, 142 frames. Okay, so here we go. Frame number 1, for example, 2, and so on. Now, notice right at the end as well, though, we've got something called frame data. All right. So I was asked this question, I think it was last week, Friday, can single store, and I think the gentleman that asked the question was implying, could you store like embedded, multiple vectors, arrays of them together? And the answer is in the vector type, no, you can't do that. So if we were storing this in the database, this would be fine. This would not be fine. So here, what it is, you can see there's a level of embedding. Okay, can you see that? And then what it is, we've got the RGB values for each pixel, I guess. So that is being, if we want to store this in single store, we currently would need to choose something like a text field or something in order to store that. So currently we can't use that in the vector type. Now, whether that will change in the future, I'm not sure. Okay, again, that's a question for engineering, question for customers, that if you demand it and you request it of single store, I'm sure they will put the time and effort in to do that. But that's the way it currently stands. Okay. One useful thing then is to just verify the length of the embeddings in the frames. Let's just check that, and that's all we're doing here. So we can see that of the 2 columns, the minimum length for the embeddings is 512, and the maximum length is 512. That's great to know because that means it's consistent. Okay, everything is 512 dimensions in length. And then for the frame data vectors, it's 1080. Minimum and maximum. So you can see a slight difference there, but that's a separate thing. Okay, and we're not really concerned about that. In actual fact, we could ignore it because we're not really using that. It's the embeddings that we are more interested in, the 512 dimensions. The next task here is just to normalize that, fairly standard process. And then finally, we get to the point where we can actually use that to do some similarity calculations by inputting some text. Or choosing an image that we can use to compare against the list of images that we have already. And so in the first case, we will choose a text query, encode the query string. Again, we need to represent that text phrase in a vector representation. So this is the code that handles that for us. And then here, this is a bit more interactive. So we simply prompt the user to say, okay, enter your query. And the query that I've opted for is ultra-fast ingestion. Now, the reason I chose that is because in the video that was playing a little bit earlier at the top, if you watch all 2 minutes, 22 seconds of it, you'll see that along the way, there's a slide or two, or for a couple of seconds, you'll see that one of the frames contains the phrase ultra-fast ingestion. So that was the reason. Now, could we actually find the appropriate frame within that video? That was the reason there and the thinking behind this. So if we do that, we can do the top 5 best matches. search for that text phrase in those frames. And here it gives us the similarity, and it orders it according to the highest value being at the top. Okay, so there you can see. And the next task, just using matplotlib there to actually plot the frames there. And there you can see we have frame 40, okay, and frame 39. And there you can see the phrase ultra-fast ingestion, okay. There, once we get beyond that, we actually don't see that. But, like I said, in this particular case, I would guess it's probably wise just to select the best match. I've just shown 5 simply because I was interested to see, what the other 4 would look like. So it's done a pretty good job. We've been able to find the matching text pattern within the image, and we know exactly where that occurs. So that's great. So that works well. All right. So the next task then is to say, okay, we've been able to take some text, the search for a text pattern within the individual frames that we've separated out. How about if we wanted to try and match an image? And so this is what we're doing down here. And then again, what I've done, I've downloaded one of the thumbnails, okay, from the GitHub repo. And this is the very first frame, very first image that we have in the video once it gets started, okay, what makes single store DB unique. So, and again, you will have seen this on Friday last week where we used these thumbnails as well. And again, we take that, we try to match it against the list of sort of frames that we've been able to extract from the video. And here, again, you can see we search and retrieve the top 5 best matches. So it tells us that frame 7 is actually the best. And again, we just plot this and show the frames themselves. And indeed, we find that frame 7, we have a good match. Here you can see not quite so good, a little bit blurred here in terms of the text. And then the rest of it, again, you can see, well, the pattern doesn't appear there, but it may be, simply the choice of having these kind of 1-second intervals in this particular case. Take the time and opportunity to review the video and look at the results here. But in this case, again, probably what we are interested in is the best match. In other words, we could ignore all of these, okay? And then this is the thing that we're really after. Can we do combined queries? Can we combine both the text and the image together? We can. And then Clip gives us this opportunity. And then here we are doing exactly that. Now, in this particular case, because the text is not something that appears in the image, ultra-fast ingestion appears nowhere here, okay? But we do have this, the what makes single store DB unique, and we know that this matches well. But we take the opportunity to kind of balance this out and give equal weighting to the text pattern and equal weighting to the image, which we talked about previously as well. And again, if we take the opportunity, we do the similarity search. And by the way, the similarity search is cosine similarity that it's doing here, okay? We get the best matches here. So showing the frames again. Now, in this case, you can see that overwhelmingly, it's the image that seems to have come out better. And again, checking all of these results, very similar to the results that we obtained using the image. So there may be some, adjustment we need to make in terms of the weighting. Rather than giving equal weighting, perhaps we want to weigh the text a bit more, for example, give that greater weight in terms of the search. Or maybe we, overwhelmingly, we are happy with the fact that the image seems to be the dominant factor here. And that's it. That's all. All of this is self-contained. Clip handles all of this for us. The software will generate the, you saw the encoding. We get the vectors. We can perform these similarity searches using cosine here, for example, and we have the opportunity to both use the text, the image, or a combination of both. And again, we have the flexibility to weight that as well. Whether we want to give more weight to the text, more weight to the image, or perhaps just keep it even. And finally, then down here, database operations, we can store all of this directly in single store, very straightforward. So we just take the data frame, a little bit of conversion happening here, okay, just to string representation. There's several ways that we could do this with single store. And then again, if we take a look at the data frame itself, very similar to what we saw a little bit earlier. And given what I mentioned earlier about the frame data, we could actually leave this out if we wished to do so. It just so happens that this is generated as well. I thought it'd be useful to store this too. Here, all it just checks is that we are using the shared tier. If so, there is no need to create the database. It's already done for us. If we are using the standard tier, it will create a database for us called VideoDB and drop that and create that. Okay. And then finally, just using this SQL Alchemy. And here we're just creating the table. Okay. So for the vector embeddings themselves, okay, it's 512, okay, to match what we used earlier. And then for the frame data, because of the current limitation in single store in terms of nested vectors, we're just using text there to store that information. Okay. And we can write that directly using the toSQL from Pandas. So you can see it's 142 rows, okay, 142 frames, 142 seconds worth of data. And then just as a sanity check, just retrieve the data back. Okay, now this will be a little bit interesting. So here we're just pulling one row back from the database to take a look at it, and it happens to be row 21. And notice that you can see this representation. So this is kind of the internal representation of that. We can convert this back into an array if we want, but this is the kind of internal representation of that. And the text for the frame data appears as is because that's just a text field. Okay. On top of this, we have the opportunity to add an ANN index if we wish. We can do that. Lots of options available here. In this particular case, I've opted for just auto, leave it to the system, and it's going to use the dot product. Okay, so remember, by default, single store supports dot product and Euclidean out of the box. And so we'll choose one of those options. But this is well documented in the online documentation that's available. Many, many more options available. Okay, again, because of time pressures, we don't have the opportunity to discuss that in detail, but that's something we can do. Now, again, because we're dealing with a fairly small data, okay, it's only 142 rows, using an index here is probably not going to be very useful. But once we scale up into thousands, tens of thousands, hundreds of thousands, or millions of rows, this would be very useful. So adding this ANN index, what we lose is perhaps accuracy. What we gain is speed. So the ability to query the data is going to be very fast, but we may not get everything back that we expected. And if we are prepared to lose a sort of some degree of accuracy, that's fine. I mean, that's why it's called ANN, approximate nearest neighbor. Okay. If you don't add this index, what single store will do, it will use KNN. No index, I mean, it'll still be very fast. Certainly for, millions, possibly tens of millions, but you can get away without using the index. That will work fine. But again, if you're going to scale up to much larger data sets, data sizes, using something like an ANN index may be the way to go. And then we can just do an example query here. One quick word here is you'll see this SQL magic named parameters in the notebook you download. It will be set to true. I just tried to run that earlier and it's been deprecated. So now you have to say it's enabled. Okay, but it'll still work. You'll just get a warning message. I will update the notebook and push that out to GitHub. But it's a very minor thing that has just changed since I last ran this. And then with single store, again, you have the option of querying. If you've created the ANN index, you can choose to use it or you can choose to ignore it. So in this particular case, we are saying ignore it. This is what this does here. Okay, so use index and notice it's empty. Okay, so that's actually telling the system don't use the index. And if we take a look and run this, so you'll see here the frame number 76943, and it gives us the similarity score as well. Okay, and this is using dot product here. Okay, this is the shorthand that you can see in the middle. This bracket, star, bracket. Okay, and then just down below here, we'll say, okay, use the index. All right, and you'll see the identical results being returned there, 76943. And if we go back here and just take a look at what we obtained previously when we were running this, we've got 76943 here as well. You can see top 5 best matches. So there it's cosine. Okay, so you can see the value is being returned, and the fact that we're using dot product here, despite it being cosine earlier, is fine. The results come back as expected. There we go. Okay, and then just a little example there of how you could do that using Python. Okay, if you wanted to get the results back into a data frame, so that's one way you could do this. Okay. Now, I mentioned some limitations. So frame extraction. Frames are extracted at a fixed interval based on the frame rate. This could miss important frames or include redundant ones. You saw a little bit of that happening in terms of the results that we saw earlier. Embedding generation, batch processing multiple frames at once to use parallelism should improve performance. Okay, I think for this scale, it works fine. Not too much delay. The main problem was simply doing the frame extraction, which, as I said, took 6 minutes for a video that's 142 seconds in duration. That's too long. If I've got something that's like an hour or 2 hours in duration or longer, that's not going to work very well at all. And then the similarity calculation. Similarities could be parallelized to speed up computation, especially for large videos with many frames. And I think that's really talking about that in the Python itself versus single store. In single store, creating the index is very straightforward. Doing the queries is very straightforward. Again, if you check the sort of results of the SQL queries, for example, you'll see you're talking about milliseconds here, for example, 147 milliseconds. And then going back here is 320 milliseconds. So, this aspect of it is very fast. But working with the Python might take a little bit longer there. Okay, so let's go back. Just keep an eye on the time. So great, we're going to finish early today. I think that will make Yuxi a little bit happier. So just a couple of words. So if this interests you and you're thinking about the possibility of perhaps utilizing single store for some real world problem that you have, or as a drop-in replacement, remember single store has two benefits as far as working with other technologies. One is that it's MySQL wire compatible. So if you are from the MySQL world, most of the commands will look very similar. The tools plug in directly. I use the MySQL CLI, for example, as a way to just connect to single store. It's awesome, very straightforward. We are also MongoDB wire compatible with single store Chi. So those are very useful ways to be able to bring your skill set, the existing tools that you work with, and you can use them directly with single store. So there is a planning and execution program, assessment, design and plan, migrate and validate, post-migration support, cutover support. My colleagues in the solutions engineers, solutions SE team globally work with customers on these, and we can handhold you through this entire process. Very useful, and we can work on them POCs and things. The customary, we are hiring, so if you're interested, singlestore.com/careers/jobs. Okay, there are openings globally that we have. Take a look at that. And my favorite phrase, any sufficiently advanced technology is indistinguishable from magic. Okay, so hopefully that's been helpful for you. If you've attended all three of the webinars, thank you very much for your time and for your attention. Hope it's been useful for you. So I'm a great advocate of free and open source software, and I try and use it wherever I can, simply because I like to use it. And it's great not to have to get your credit card out and have to pay for stuff, if there's great free stuff available. And in the past, I've also used Whisper from OpenAI, which I think is awesome, does a great job. I mean, you can use their commercial offering as well, but it's free. Clip is free. Recently, OpenAI also released Swarm. Okay, so if you're interested in agents and agents working together, and again, they do have the caveat that this stuff is for education. Don't use it in production environments, but that's fine. Okay, as long as you're aware of that and you are prepared to understand the limitations and restrictions around that, that's great. That's okay. But utilizing this can work really well. Clip, I think, works really well. Gives you the opportunity to use a kind of a shared space for images and text, and you can see that it's very straightforward. Once you have the data, once you've got you were using some encoder and you've extracted out, you've got the vectors, you can store them very easily. If you want to work purely in memory, that's easy to do. Okay, pandas there, or if you want to use some kind of vector library face or something like that, that's fine. Equally, storing in a database system for kind of long-term memory, you've gone through the time and the effort of constructing these vectors. You can store the data, you can create the indexes, you can search this data now, and you don't have to go through that process of having to recreate all of these vectors again. I think the key issues around CLIP generally, and the observations for for these three webinars that we've done, is that the bottleneck tends to happen outside of the software itself, in my opinion. So it's, for example, it's just simply getting hold of images from, say, a content delivery network, CDN, make sure I get that right this time. And if you can store them locally, I think processing that is going to be a lot faster. The video processing in this particular notebook, again, slow. There may be better ways to do this. But I think once we have the data and we've extracted out the individual frames, whether it happens to be 1 second intervals, as we saw in this example, or you use some other way in order to do that, it's very easy to process the data and to be able to do these kind of interesting searches, comparing images against images, and then doing text against images or images against text, for example. And whether you would like to use a combined approach as well, that's possible too, because you've already got the representations of the data, if you like, and giving appropriate weighting to that, whether you think that the image should have greater weighting or the text should have greater weighting. Again, there's flexibility around that as well. Okay, so with that, I will stop there. So you see, we've got 10 minutes or so. So today I finished early, which is unusual for me. So let's take a look and see if we can have a look at the questions then. So hopefully you've shared all the links to the resources. All right, there we go. Okay, there we go. Let's see if what can Swapna, hi Akmal. Yes, hello there. Thank you very much. Loading notebook runs forever. Is there a way to include audio transcript from that video into embeddings? That's a great question. I haven't really looked at that, Ranga. Thank you for that question. So that's an interesting proposition. So with Clip, it will handle images and text. Audio, as far as I'm aware, is not managed by that particular piece of software. I mean, OpenAI does have something called Whisper, but that's just for if you like, transcription. So you can speak, you will get an audio file that's generated, and then from that audio file, you can use Whisper to generate a transcription of what you've just said. And depending on the model that you use, what I've tended to do in the demos that I've done is I've tended to use the smaller and medium models simply because I don't have the space on my laptop to be able to run that locally at the larger scale. Usually I use a virtual machine, which I give half the resources of what I have, and that's kind of 8 GB. And, for virtual CPUs, that seems to work well. But I'd need to look into that to see if the audio component of it. I'm sure there's a solution to that, fairly easy one. Okay, because if you think about it, at the end of the day, the sound file can be converted and transcribed fairly easily. That's not a big problem. And we could then use that and store the representation of that. Okay, it's just going to be text. Okay, and then text can be easily converted using vectors as well. So there's nothing very particularly challenging about that, but I think it just involves a few extra steps to handle that. ANN, yes, approximate nearest neighbor. Okay, so that's what it is. So the ANN, Ashish, is the mechanism that we can use that we are prepared to sacrifice accuracy for speed. Okay, so this is what ANN indexes tend to do. You've got large quantities of data. It may take time to get results back, but you are prepared, say, 80, 85, 90% levels of accuracy. You may have some important business decision that you want to make. You cannot wait, minutes, potentially hours. If got large quantities of data, ANN will be able to return you a result very, very quickly, but you lose the accuracy. I mean, that's essentially the benefit that you get. There is a downside to it as well. Yeah, example of the seminar mentions about fox and dog, image, text, and audio. How can audio query work along with quick? Yeah, I think Rajaram, your question is very similar to the earlier one. So in this particular case, Clip can handle the image and the text. Audio you'd need to do separately. Okay. But it's a great question. I'll give it some thought, okay? And if I come up with some solution, what I may do is just write an article and then build a notebook around that. But that's interesting food for thought and something that I'll put on my kind of to-do list. So certainly you can do two of those. The third one I've tended to do just separately by itself. And it's a great way to, if you combine it with something like LangChain, for example, the audio, use Whisper from OpenAI, for example, which again is free on GitHub. Just speaking, having the software capture the voice, do the transcription, create an MP3 file from that or whatever, and then you transcribe that into text, take the text, convert that into vectors, and now you have a means to be able to query. And if you use something like the SQL database toolkit from LangChain, you can ask these natural language queries. And so one of the demos that we have that I've done is stock ticker. Okay, stock ticker data coming into single store using pipelines and a Kafka feed. It's made up data, but then I'm asking in spoken language to the software, show me the best performing stock. What it does, it goes away, creates a recording of my voice, transcribes that, and then using LangChain, this kind of natural language, asks that question of the database, returns a result. Sometimes it doesn't know the answer. It just says, I don't know. But generally speaking, the transcription is very, very good, highly accurate, and it supports multiple languages as well. So have a look at that. Okay, Whisper is awesome. Language support varies. Some languages are supported better than others. So if you're from South Asia, for example, things like Urdu and Hindi and Bengali, I think are less well supported than some of the European languages. I think that the best language, off the top of my head, I think something like Spanish, for example, and English, obviously. But the level of support varies based on the language. It's not the same everywhere. Yeah, one of the things that we noticed, and I think there's a question here in terms of the keeping in mind that the number of tokens as well that Clip can handle, as far as the text is concerned, is limited to 77. That's a limitation I hit on Tuesday earlier this week. So if you look at the notebook and the recording for that, you'll see that we reduced it down to 70. So, okay, I mean, that's a reasonable amount of text that you can use, but it's not infinite and it's not endless. So you would have to deal with that slightly separately. Okay, so Francis, you've got a question. I'm just starting to assist regularly, but this great tool is more for diverse projects like project management in marketing and mentor, or just for the coding world or creating like AI. Yeah, Francis, so great question. So you're essentially, if you're asking about Clip itself, I think it's a very useful tool if you want to work with images and text. And then let me just show you something here, which we talked about earlier this week. Okay, I promised I would bring this up. So where we were working with, for example, building an e-commerce site. I mean, I didn't show you a demo of a working site, but what I showed you were the elements of one. Here is the actual example that you can look at, that we use some of the technologies that we've talked about. In this particular case, it's not using Clip directly, but if you want to have a look at this, okay, it's a single store hyphen estore.com. Okay, so this is a fully working example that takes many of the images that we talked about on Tuesday this week. So these are items of clothing, bags, t-shirts, I think other things as well. And we've encoded that for you uh, using OpenAI, but it does so on the description, okay, short description and a more detailed description. So they're like the title, if you like, of what the item is, say a pair of shoes, for example. It could be that could be a simple description, or a more detailed description to say, oh, a pair of shoes, black in color, a size this, and so on and so on. You know, and it's men's shoes, for example. Much more detailed description. So we've provided that for you, and then here you can see a full working example. So I could type in here, say pink shoulder bag, which I used the other day. And let's see if it will just simply take that. Okay, so there you go. So this is an actual working example, but this does not do the search on the images, purely on the textual text description and the title. So the point that I was trying to make on Tuesday is that there's nothing to stop you from taking advantage of something like this purely for images as well. And remember, this is just one example. So think about many other domains where you're working with images and text, for example, where you might want to match. So if I wanted to, maybe I could extend this and then add an additional box here, or some kind of upload image option for the user to say, okay, you have a particular favorite pair of jeans, for example, or a favorite dress, or a favorite t-shirt, or a favorite handbag, or whatever. Upload the image, and then I can search based upon what you've uploaded, try to match that in the e-store that we have, and then show you other similar items to that. That could work really well. That would be a bit unusual. I mean, I don't think anyone really provides that, but I mean, this is a kind of an extreme example, right? But there may be many other problems which that kind of scenario could be very useful. So having something like Clip is helpful. I mean, it's just one of many possibilities. A lot of these open source commercial LLMs now, if you think about it, they support images, video, audio directly. You can get Whisper support directly from OpenAI if you want to pay them for the privilege to do so, or you could use their open source freely available offering as well. So it's a question of what your priorities are and how much you're willing to pay. And a bit of an experimentation, I think, would work really well, and I think it could be helpful. So with these tools, you may not think of a use for it today, for example, but 6 months from now, a year from now, you might say, I attended that webinar. That guy talked about this software. I have a problem today for which I think that might be really useful. It's just another tool in the toolbox, and something that keep your eyes on, because this whole space moving very, very rapidly, extremely fast. More so than, in my entire IT career, I have never seen things moving this fast paced ever. So there we go. Okay. Okay, Lucy, you've got a question. Could you remind me the LLM used for the embedding demo today? None. We didn't use anything. Okay, so we used an encoder. We used something that's, Torch Vision, Torch Audio. If you look at the code, okay, we're not actually calling any LLM itself, which is great. You're not paying money to anyone. Neither are you using anything open source, okay, which is really going to work well. Vijay, you got a question. Are there any statistics on performance and accuracy compared to other vector databases? Great question. So there is well, in the world of database systems, there are three global conferences that are well known. There's VLDB, ACM Sigmod, and IEEE Data Engineering. And SingleStore, I believe, has presented papers at several of these conferences over the past year or two. So I think the last one was VLDB, which was in, I think it was Guangzhou, China. There is a paper for that. And again, if you're interested, drop us a line. So we've done some competitive comparisons, performance comparisons against some leading vector databases, and SingleStore is very competitive. Okay. One of these things about performance, I'll just say this, is that years ago I was an academic and I spent 6 years of my life doing performance benchmarks at a time when the hot technology of the day was object-oriented databases, something you may have heard of, okay, or it may be before your time. Benchmarking is very hard, I would say. And it's one of these things that you have to do like an apples for apples comparison to make it fair. And sometimes vendors put in commercial clauses that prevent you from publishing results. Generally for open source, it's okay though. But again, just drop us a line, team@singlestore.com. And what I can do is I can ask Yukti actually to include a link to the paper if we have it online. I'll find the link, okay? See if it's available online. We can share that with you. And again, if you want to do some competitive benchmarks, we can help you. So bear in mind that SingleStore is not a dedicated vector database. A vector support is part of the overall offering. It does other things as well. And that's the if you like, the beauty of the solution, in the sense that you may require vectors for a part of your overall requirement, your overall solution. You've got other things that you want to do. Maybe you want to handle time series data, some geospatial data. Perhaps you just want raw SQL, standard SQL, just treat it as a relational database. Oh, you might want to do some MongoDB compatibility. And then you might have some need for some vector support. So this is the benefit that you get with SingleStore. Okay, great. So let me just keep an eye on the time. Right. Yukti, I think there's more questions than I can answer, and we are just past the top of the hour. I know it's very late for you in India as well, but I think your promise is that any questions that are asked, we will answer all of them, and we will follow up with all of them. So if there's anything that I missed today, I apologize, and we will get back to you. But again, anything in particular that you would like to follow up on, just drop us an email, team@singlestore.com, okay? And we'll be very happy to connect with you. Okay, now I think that's a US phone number, but the email should work globally wherever you are in the world. So there we go. And with that, I'll hand back to Yukti.
All right, thanks, Akmal. So I see just one comment from Lucy. She says that thanks, Akmal, great session. Is there a way to access the previous session, the one on Tuesday? So you will be emailed with the recording, or maybe like, I think the landing page should be updated, so you can just request for a video on demand. But if you registered, don't worry, you will get a follow-up email from our team. So stay tuned for that. And I believe that a lot of people are actually on a break, so that is why it's kind of getting delayed, which is all right. So we'll make sure to send it over to your inbox really soon. So yeah, thanks Akmal for hosting this session, and thanks everyone for joining. We really appreciate your time and energy, and stay tuned for the next session that is there on 16th, right? Full text version, right? All right. So thanks everyone for joining. Have a